All right, this is for you to review your Chapter 6 study guide. Make sure you have that with you because the questions come directly off the study guide and you'll see them posted at the top like you do question 1 here. So question 1, what are the 3 subatomic particles of an atom and what charge do they carry? The easiest one to start with is protons, and they carry a positive charge. You can think of a positive charge, protons, they both start with a P. The next one is a little trickier for students, and I'm not sure why, but when they hear the word neutron, they automatically think it carries a negative charge, but that is not true. Neutron doesn't sound like negative to me at all. I mean, the NE, I guess, but really neutron sounds more like neutral, and it carries a neutral charge or no charge. And once you got that done, there's only one left, and that's the electron, and that carries a negative charge. So where do I find the subatomic particles of an atom within the atom itself? Where would I find the protons? Simple. That's going to be right inside the nucleus or in the center of the atom. The second subatomic particle we did were neutrons. You're also going to find those inside the nucleus. What about the electrons? Those aren't going to be inside the nucleus. Those are going to be the outside of the atom. And we say they orbit the outside of an atom. And when we say orbiting, we don't mean like the planets do around the sun. They're on the outside of the atom. And this right here is the mathematical formula for how electrons orbit around the atom and how much energy they actually carry. You don't need to know the formula for this test. We'll do that later on this year. All right, number 3, how does a different number of neutrons affect an atom, and what term do scientists use to classify it? So we're looking at a different number of neutrons, not a different number of protons, because if we change the protons, we're changing the element itself. So it's a different number of neutrons than protons, not a different number of protons than neutrons. So when protons and electrons are equal, there's no charge, or we say there's a neutral charge. Now when the protons and the number of neutrons is different, this creates what scientists call an isotope. What does that mean? It means it becomes radioactive. So an isotope is a special word to describe an atom that has a different number of neutrons than protons. Now, here are some examples of some isotopes. Carbon-12 is not an example, and that's because the protons and neutrons are the same. And when we look at this definition, when the protons and the number of neutrons is different. Well, if these are the same, carbon-12 cannot be an isotope. Carbon-13 is, however, because we have 6 protons, we have 7 neutrons. They are not the same number, and if you're wondering where we're getting this carbon-12 and 13 from, we're simply adding the protons and neutrons. So carbon-12, 6 plus 6 is 12. Carbon-13, 6 protons, 7 neutrons. And then carbon-14, 6 protons, 8 neutrons. 6 plus 8 is 14. If I change the number of protons from 6 to something else, it would no longer be carbon. It'd be something completely different, and that's why the number of neutrons is different, not the number of protons. All right, moving along, number 4, compare and contrast elements and compounds. So a compound, pretty easy. You can think of compound words or any other compound. It's 2 or more things joining together. We also have the word molecule. Now, a compound is composed of 2 or more atoms or elements that are different. When we hear the word compound, there's 2 or more atoms, 2 or more elements, whatever you want to call it. It's going to be different. They're not going to be the same. A molecule, 2 or more atoms joined together, but they can be the same element or different. It doesn't matter. So all compounds or all molecules are compounds because they can be the same or different. If it's a molecule, it can be a compound. All compounds are molecules. That's what we're looking for. Because 2 or more atoms or elements that are different, that is a compound, and all compounds are molecules, but not all molecules are compounds. And we'll talk about why right now. So when we look at this picture, let's look for the compounds first, because that's the first word we had. And we're looking for the atoms or elements that are different. Well, here I have H's. They're the same letter. Here I have O's. They're the same letter. Here I have N's. They're the same letter. Here I have Cl. They're the same letter. So the compounds down here, I have 1, 2, 3, 4. N and O, not the same letter, 2 different atoms joined together. H2O, we have H and O, two different letters. That is a compound. Nitrogen oxide, we have O, we have N, not the same letter. Therefore, it is a compound. Carbon dioxide, we have O, we have C, not the same letter. Therefore, it's a compound. When I look at molecule, they can be the same or different, it doesn't matter. Are these the same? Yes, it is. It's not a compound. It is a molecule. We have 1, 2, 3, 4 molecules. But if I look at the definition, it says they can be the same or different. Well, these are also different. So we have 8 molecules, 1, 2, 3, 4, 5, 6, 7, 8, but only 4 compounds. And it comes back to the definition of compound and molecule. If it's a compound, the elements have to be different. If it is a molecule, they can be the same, like they are here at the top, or they can be different. It doesn't matter. A molecule is going to describe 2 or more atoms joined together. It doesn't matter if they're the same or different. So make sure you look carefully at that one. Number 5, how does the gain or loss of an electron impact the charge of an atom, element, or compound? Well, when we have the gain of an electron, we call that an anion. And you got to remember, you can't gain or lose protons. Now, when you gain an electron, you now have more electrons than protons. And when you have more electrons than protons, you ask yourself, what does an electron carry? It carries a negative charge. Therefore, the atom, the element, or the compound will have a negative charge. If you lose an electron, because you cannot gain or lose protons, if you lose an electron, we call that a cation, you have less electrons than protons, which results in a positive charge. So that's how it works. When you have less electrons, you have less of a negative charge. When you have more protons, it's going to have a positive charge. So compare and contrast a solution and suspension as well as a solute and solvent. So this is a great picture. We have a suspension here, and that is a mixture of sand and water. Sand does not dissolve. You can separate them by filtering the sand from the water, and that is, the sand's not dissolving, so it's not a solution. There's no solute or solvent here. It's just a suspension, and most suspensions will have the solids settling at the bottom. Not always. Now, a solution on the other hand has a solute and a solvent. So it's very important to know those 2 words. So in this example, they use sugar and water. You can use salt and water, anything that will dissolve. So let's start with the sugar here. The sugar is what we call the solute. The solute is what is being dissolved in the liquid. The water in this scenario is going to be the solvent. It is what is doing the dissolving. It is causing the salt to dissolve. So the solute, what is being dissolved, water, what is doing the dissolving to the substance. And when you mix these 2 together, sugar is dissolves in the water. That's why it's the solute, and water that dissolves the sugar, the solvent, that makes a solution. So a solution has a solute and it has a solvent. So one more time, sugar is the solute, what is being dissolved, water, what does the dissolving, and we call that the solvent. And when you have a solute and solvent, you have a solution. If you doesn't mix and dissolve, then you have a suspension because the items are suspended inside the water. All right, how does an individual read the pH scale, and how would one determine if something was more basic versus more acidic? And what about neutral? So you guys have been doing really well in class. I don't think anybody's going to have a problem with this. Of course, it's not knowing the pH scale, it's knowing how to apply the pH scale. So here's our pH scale. We know it ranges from 0 to 14. My acids are 0 to 6. My base is 8 to 14, with neutral being pure water, smack dab in the middle. So my stronger acids are closer to 0. And the reason they are stronger is because I'm moving away from the neutral zone. I'm not getting to pure water. I'm moving far away from it. And the farther I am away from neutral, the stronger the acid or base. Well, I know bases are 8 to 14, and I know my strong bases are going to be right around 13, 14 because they're farthest away from neutral. So, and then I have my weak acids, which are going to be 5 to the high 6s because they're right close to neutral. My weak bases are going to be 9 to the low end of 7 because they're very close to 7. And then my strong bases down here, just like we said. And water is neutral. Pure water is neutral. There's nothing else in it. It will test. Pure water should test at 7.0. All right, so what's the function of a proteins? Well, we talked a lot about this in class, especially focusing on enzymes, some proteins that are the enzymes that are made up of proteins. But there's some other things they do. They help move substances in and out of the cell. They help fight off disease. Now, there are other things that do that too, and we'll cover that more in depth later this year. And they act like an enzyme, helping to control the rate of reactions. Now, when we talk about controlling the rate of reactions, they speed up the chemical reaction because they lower the activation energy. When you hear lowering the activation energy, that doesn't mean that the process is going to slow down. A lot of students confuse that. By lowering the activation energy, we don't have to wait as long for more energy input. It can actually start faster. So because we lower the activation energy, the activation can start much faster. It does not store genetic information. That would be RNA and DNA, and that would be a nucleic acid. And I know that because the NA in both RNA and DNA stands for nucleic acid. It does not store genetic information. We had some confusion a little earlier. All right, let's keep pressing on. So what is the difference between products and reactants? The first thing you want to look for is the arrow. The arrow will split up the chemical formula into a left side and right side, but it's not just knowing it. You got to know what they mean. So the reactants, they're required for a chemical reaction. The reactants react together to make products. This is the result of the chemical reaction. So here we have a chemical formula, which is, let's see here, that would be H4O2, whatever that may be. And so we have reactants. Here's my arrow. That's what I'm looking for. And I see the reactants are always going to be on the left side. They react together to get the products, which will be on the right side of the arrow. So reactants on the left side of the arrow, this arrow right here, that means yields not equal. The products on the right side of the arrow. So pretty simple there, nothing too complex. Number 10, so what does a chemical reaction do? We talked about a chemical reaction. What does it do? Well, it chemically changes one set of chemicals into another set of chemicals. Here we have sodium, and we watched a video at the beginning of the year where students dropped it into a beaker, it caught on fire, and then exploded. Seems pretty dangerous. Well, it doesn't seem dangerous. It is dangerous. Chlorine gas will kill you. So here we have two dangerous items, but when they're chemically combined together, they become stable, and it makes table salt. So it becomes stable and makes table salt, and we have a chemical reaction here. They have chemically combined and turned to a different set of chemicals. All right, number 11, what is the activation energy? This has to do with the chemical reaction, and the activation energy is to activate the reaction. What does that mean? Well, pretty easy. It's the energy needed to start a chemical reaction. It actually begins. You guys did really, really solid on that this unit, so I think that will be a one that everybody gets. So here we have a chart. We have the reactants. The activation energy happens, and we end up with products. Now, looking at this graph, we can see this graph gives off energy. How in the world do I know that? By looking at this graph, that's a great question. Right down here, we can see the end result of the energy. So this side right here represents my energy. The higher the red line, the more energy I have. And so down here, not a lot of energy. I have less energy than what I started with. And because I have less energy than what I started with, I know this has given off energy. If this red line was higher than the reactants were at the beginning, then it would be absorbing energy. Now, what makes up a catalyst? We're talking about the catalyst inside our bodies, and how does it affect activation energy? So we kind of touched on this a little earlier. So we call these catalysts enzymes. Now, not all catalysts are enzymes. These catalysts lower the activation energy required for a chemical reaction, and therefore they're going to speed it up. So if I look at this graph right here, this is how much activation energy I need. That's a lot of energy. By using a catalyst, I can lower the activation energy. I don't need as much. And because I don't need as much, it's going to happen a lot faster than it would without a enzyme or catalyst. So it lowers the activation energy. And because it lowers the activation energy, that chemical reaction is going to happen much faster. All right, we're almost done. Only 3 slides left. So let's see here. We have 14, 15, 4 slides left. So we're almost done. What is the difference between cohesion and adhesion? So here we have co. Co means to come together. What's coming together? Water. So it's when water sticks to water. Water is attracted to itself. It is a polar molecule. But cohesion is describing water sticking to water. When we did the penny and the water drop lab, you saw that water was sticking to itself. The penny held many drops of water. We even had one group that held 60, I believe it was 61 drops of water. If I was not standing there, I would not have believed it, but I actually saw them count out 61 drops. That was pretty impressive. Congratulations to whatever group did that. I want to say it was Group 6 in 3rd or 4th period. I want to say it was one of them. So congratulations. Then we have adhesion. Well, if cohesion is water sticking to water, what is adhesion? That's water sticking to anything else. All right, it's sticking to something beside itself. We also talked about the Jesus lizard. I'm not trying to make fun of religion. That's what it's actually called. It is called the Jesus Christ lizard. So here we can see these water drops are sticking together. The polarity of the water and the multiple hydrogen bonds is causing the surface tension for the Jesus lizard to run across the water. This is not shallow water. This is deep water. He can run across, which is why it's called the Jesus lizard. Then we have adhesion, and adhesion would be where the water is touching the side of this beaker. Is there cohesion happening in here? Absolutely. We're in like towards the center and not near the glass where water's sticking to water. But where the water is touching the glass, that would be adhesion. Water is sticking to the glass, not itself. So cohesion and adhesion both happening here. Adhesion on the very edge of the inside of the glass where the water is sticking to the glass itself. All right, number 14, compare and contrast a covalent and ionic bond. These are how atoms join together, usually through a covalent or ionic bond. So here we have the word co. You can think of co-captains. They share responsibilities. And a covalent bond, the electrons are shared. It's simply when two or more elements are chemically combined due to sharing an electron. An ionic bond, there's no sharing. It's a transfer. So when two or more elements are chemically combined by the transferring of an electron. This one right here, very easy to miss. Not so much that it's difficult. It's because it's pretty easy. A lot of students don't study this. They say, oh, I'll remember that. And they end up getting a little nervous on the test. And they end up missing this one. So make sure you study it and study for the long term, not the short term. How does a sodium atom and chlorine atom become bonded, and what is the transfer or shared electrons, depending on the type of bond that we just talked about, due to the sodium atom and chlorine atom? Well, they become bonded by an ionic bond. You don't need to rewind the video because I have the definition right here, just like I did. It's when two or more elements are chemically combined by the transferring of an electron. So they transfer an electron over, and when they become chemically combined through an ionic bond, they become stable. And this makes the atoms become stable, and that's why it's safe to consume table salt. Nobody puts salt on food and worries about their chest exploding from the sodium or their chest feeling like it's on fire and dying from the chlorine. It's sodium chloride. It becomes stable. All right, you made it to the last one. How are enzymes beneficial to cells in our bodies? So they do a lot of things here. The enzymes lower the activation energy required for chemical reactions, and because they lower the activation energy, they speed things up. So they regulate chemical pathways in our body. They make materials that cells need, and we'll talk about that more next unit. They also release energy, and the energy that they release comes from chemical reactions that release energy stored in our food. So 5 things there, quite a bit, but nothing that you can't handle. That's it for the questions. Your test is on Tuesday or Wednesday, depending on when you have class. If you have any questions, please do not hesitate to text me through Remind. You can leave a comment below, and we'll see you guys in class. Have a great weekend.